Welcome to the online lecture series on 8051 microcontroller. In this video lecture, we shall discuss in detail about the sequence of events whenever a call instruction occurs. Okay, this is a very important lecture to understand the mechanism of how a call instruction and a return instruction operates. Okay. So first I will explain this mechanism with an example program. Okay. So we know that the instructions are executed sequentially. Okay. And the program counter, that is a 16-bit register, it holds the address of next instruction. Okay. So your program counter is a register which actually keeps tracks of the addresses of the instructions. Fine. So we have seen this earlier. Okay. Now we need to see what all happens when a call instruction is executed. Okay. Now for that, it is important that we will note down what will be the contents of PC. Okay. So since we have started with 0h, so the address of the program counter will be 000h for the first instruction. What will be the address of the next instruction? The address of the next instruction, it depends upon the number of bytes this instruction takes. Okay, what we call this is the length of the instruction. That is what I have asked you to write in the laboratory record also. So as you can see, one byte is always taken by the opcode, and the second byte is taken by the immediate address. Okay, so the next address will be 2 bytes of this. So 2, the earlier address was 00. So this address will be 002h. Similarly, this also takes 2 bytes. That's why this address will be 4. Okay. A call address. Okay. This also takes 2 bytes. Okay. So this address will be 6. In this case, this only takes 1 byte. Okay, the opcode. So in this case, it will be 0, 7. Fine. And absolute jump, this also takes 2 bytes. So this will be 9. This takes 1 byte. So this will be A. This also takes 1 byte. Let it be B. Fine. Now, let us see how a call instruction operates. Okay, we have seen earlier that a call instruction is also an unconditional branching instruction, meaning whenever it occurs anywhere between the program, a branching is done to the subroutine. Okay, then after executing the subroutine, it again returns back. Okay, it again returns back. So that's the difference we have noted between a jump instruction and a call instruction. Now how does it do? Okay, see, first it will execute this instruction, then it will execute this instruction. Now when the processor sees that there is a call instruction, okay, what the processor does is, now before it branches to the subroutine address, that is before it branches to this subroutine address, the processor knows that it has to again return back to this instruction. Okay, so before branching to the subroutine address, the processor saves the address of this instruction. Okay, so this address we call it as the return address. What do we call this as? Return address. Okay, what it does is it saves the return address onto the stack. I repeat, before executing that is when the call instruction occurs before branching to this address, the processor, okay, saves the address of this instruction followed by the call instruction onto the stack. So that address we call it as the return address. Okay. Now what is the return address here? The return address is 0006H, which is 16-bit address. 06 is the lower byte, 00H is the higher byte. Okay. Now how does the processor save this onto the stack? In order to save this, what the processor does is it executes two push operations. How many? Two push operations. In the first push operation, okay, I hope you remember the push operation. What happens in push operation? The stack pointer is incremented by 1 and the content is stored. In this case, so these push operations are internally executed by the processor itself. So in the first push operation, it saves the lower byte of the program counter. Okay. Then in the next push operation, it saves the higher byte of the program counter. Okay. So before it branches to the subroutine, it saves the return address onto the stack. How does it save? It saves by internally executing two push operations. I hope it is clear. Then it makes a branching and it executes all the subroutine instructions. Okay. Now in this case there are only two subroutine instructions. Okay. It may have many more also, but the last instruction in the subroutine is always the return instruction. Now when the return instruction occurs, the processor now executes two pop operations. Okay. Why? Because again it has to return back. Okay. So what it does is, whatever the contents of the program counter you had stored, okay, it retrieves back by executing two pop operations. Thereby the program counter will have the same address. So when you execute the return instruction, the control is again given to the instruction. The control goes to the again goes back to the instruction where you had left. This is how uh, uh, these are the sequence of events which occur when a call instruction is executed. Okay. Now I shall debug and also save. So here by default the stack pointer content is 07H. Correct. So when I do the push operation, so it will be stored in the memory location 08 and 09. Okay. So let me show it now. Now if you see, this is my 0 location, 1, 2, 3, 4, 5, 6, 7. The stack pointer is currently pointing here, and when the processor executes two push operations, so the contents of the PC will be stored in the memory location 8 and 9. Let me execute this. Now the call instruction is been executed. So before the call instruction is executed, the contents of the PC, that is the return address, in this case it is 06, it is saved onto the stack. So when I execute, can you see this? Okay. Now see, this is 0, 1, 2, 3, 4, 5, 6, 7. So in the memory location 8, the lower byte, that is the 06 is stored. And since it is 00 only, we are not noticing any difference here. But 00 is stored in 09. And if you see the stack pointer content, it is 9 now. Fine. Then it will execute the subroutine. Can you see here? Yes. Okay. Now at this moment you check the contents of the PC now. The contents of the PC is 0C. It is pointing to the return instruction. Okay, fine. Now, when the return instruction is executed, it retrieves back this contents of the PC. Fine, and copies this address again into the program counter. See, currently the program counter has 000C. So when I retrieve, this address is PC is replaced by the return address, that is 00006, and again the execution starts from here. Can you notice? See, the PC contains 0006. How it does? It does by executing two pop operations. Okay. So when you have executed this, again the stack pointer content has become 07H. Again the execution continues from where you had left. So that's the mechanism of the call instruction. The same has been explained in this diagram. Okay. So whenever a call instruction occurs, either it is absolute call or a long call or an interrupt. Okay. In the concept of interrupt will come later in module 5. But any one of these occurs, what happens? The contents of the PC, that is the contents of the return address, are saved onto the stack. Okay. How they are saved? The lower byte of the PC, PCL stands for lower byte of the PC, is stored in stack pointer plus 1. Okay. In our case, stack pointer was 07, so it will be 08. It depends. Then the higher byte of the PC is stored in SP plus 2. Okay. How does the processor do this? The processor does this by executing two push operations. Clear? Now, when the return instruction is executed, okay, what happens? Whatever was the address you have saved, the higher byte of the PC and the lower byte of the PC, they are retrieved. How they are retrieved? The top of the stack, it is copied to the higher byte of the PC and PC is decremented by 1. Then the lower byte is copied to the lower byte of the PC and again the stack pointer is decremented by 1. In this way, we retrieve back the return address what we have saved in the stack. The same has been explained here. Okay. First, a call instruction occurs in the program. Okay. Then what happens? Before executing the call instruction, the return address is saved automatically. This is very important. Okay. Onto the stack by the processor using push instruction. In the first push instruction, what happens? First, the stack pointer is incremented. Then the lower byte of the PC is saved onto the stack pointer. Next, again stack pointer is incremented and the higher byte of the PC is saved onto the stack. Now, the subroutine address is placed in the program counter. Okay. Subroutine address means this address, add one address, that will be copied, add one address with respect to this example. Okay. So whatever is the subroutine address, that will be copied to PC. After that, the subroutine is executed. Now when the return instruction happens, okay, now whatever the stack pointer is already pointing to the higher byte of the PC. So the higher byte of the PC is retrieved. Okay, that this is the first pop instruction. Then again stack pointer is decremented. Then the lower byte is retrieved and again stack pointer is decremented. So these are the sequence of events which happen during a call and a return instruction. Okay, we also call this as mechanism of a call and return instruction. Okay, so please listen to this lecture very carefully in detail, that how a call and return instruction are executed. Okay, thank you.